Hello and welcome. I'm Bill Wake. We're here working on a program to compare tunes for similarity, and we've come a long ways. We're working on a new report. It looks kind of like this. It's got on the left-hand side degrees of the scale, so the first, second, third note of the scale, and across the top is the measure and note number. So you see 1 to 1, 1 there. That's measure 1, note 1. The next one's actually 1, 2, measure 1, note 2, 1, note 3, 1 note C, C for common time, 4, 4. I assume it's the 4, okay? And within that column, he's taken, I don't know, a couple hundred, 284 songs and counted which note each one starts on for the first note, the second note, the third note, and so on. And so in the end, he can take the modes of those, the most common value, and draw that line he's got going to show you the sort of the average tune, or I'm calling it the melody average. It's really more of a mode, but mode is already kind of a musical word that has nothing to do with this. So we're kind of playing on the common perception, even though it's not right. And a little statistical part of me goes, ugh, but that's the way it is. Okay, so where are we? Well, we've done the calculation to say, given a note in the scale, which scale degree is it? First, second, third, or next octave up, next octave down, whatever it is. And we also did a spike to try and figure out, like, can we make a giant table with this stuff in it? And it looks like the answer is not really. There's a table object, but it only lets you have 10 columns, and we're going to have a lot more than that potentially. And yeah, so I don't know. I think we'll pursue something. We're going to pursue something very simple for now. We're going to start with just a text output, and I think we can do that pretty easily. We'll put a star by the mode just to show that, and we won't worry about drawing on it. And I think we'll manage. And then we'll see if we got time to look at the text, put it in sort of more of a grid or spreadsheet kind of look. Table, I should say. But capital T table, the object isn't going to work for us. Capital G grid has the similar problem, and we'll see what we can do. I know we can make some sort of grid or some sort of table if we work at it. But right now, we don't even have the information we need. And what we've got to do today is we need to work on a table, the model side, that would hold this information. And so what I think we're going to say is its index is sort of scale degree, since we're going to go by rows to draw it out. I think we'll make scale degree the first index, then the measure number, which I think that is, and then the scale, the note number within the measure. Now I may be wrong about these. I would think one measure would be more, one group of 4 measures. Is that a phrase? Maybe it is. It probably is. Okay. All right. So I guess that's only 16-ish entries there, depending how many phrases there are, huh? Okay. Now, let's see. So I guess we'll go to the IDE. Oh, what did I do between? Yeah. After yesterday, all I did off camera was we have a tune object, and it had the notes. And along the way, it calculated the measures, but it never made that explicit or public. So I added a method to return that. And then there were a few other places that could make use of it. So I cleaned that up a little. But we're going to do this count the scale degrees thing. So we need a total by scale degree, measure number, and note number. And also we need to know eventually we need to know the maximum. We certainly need to know how many measures are in the whole song, because no individual scale degree is going to know that, because, well, one of them is going to have the biggest, but we can't tell directly. I mean, because we're going to make it 3-dimensional table, basically, that outer dimension's not, we'd have to work to figure out the longest one. Okay. And similarly for the measures, we need to know how many notes to report in a measure. Okay, and we could sort of make assumptions it's 4/4 or whatever, but I think we want to get that from the data itself. Okay. And so we already have, I put an object in for it. No, did I? I don't think I did. Um, I've thought about putting an object in. Does that count? Okay. Scale degree we have. But I think I want to say, what is this? It's kind of an object of this average tune thing, I think. Since it's all derived data from the tune and so on, um, let's put it in there. So grid pipeline source transform. This is a sync. Oops. Parsons code. Well, let's put a folder in for average tune stage. Okay, put this in there. Okay. We just rearranged folders. 22 in the keynote. Now, I think yesterday somewhere we made some, we made some notes. I guess I should move this up here. Things we need from this table. Columns are measure numbers. It's really measure number plus note number. Rows are scale degrees. Increment for measure 1, note 2. Oh, increment cell for that. Fetch row and column headers. Fetch cell at row and column. Put star in front of modes. Okay, so we've got some requirements on our table. Let's see. Columns. All right, so let's add a new test. Oops. A new file. And I don't know the name of this object. We have to start there. It's some sort of, how about scale degree table? We can work from that. It goes in shared. Let's make sure, well, let's do something with an empty table. That's easy. What are we going to ask? Well, column number, measure number, scale degrees. I guess we could ask it how many rows and how many columns? Or maybe this row and column header thing? What should he know? Nodes, row headers. Well, let's do column headers first. That's easier. Well, it knows it has no column headers. We'll create a table and we'll ask it table.column headers and whoops. And that should be empty. Okay. And we need to make column headers. Column headers. Okay, that's going to be a thing on the scale degree table, which doesn't exist either. Tests. Okay. New file. And we've got a headers function or variable. Should return an array of strings so we can put them up top. And, well, let's just start it out with wrong. Oops. Now, there used to be a way to shift to the test. How do I do that? Control, Command, arrow. Well, that's not what we want. Huh. I feel like they may have lost that. All right, we'll do it the old-fashioned way. Okay. This one needs to be renamed. Okay. And this test should fail. Oops. Column headers. Column headers. Oh, yeah. All right, we'll just return nothing for now. Well, let's go ahead and oops. Make sure everything runs and then check that in. You know what? I actually think the first one should be an empty string, because we're gonna have the corner up here that's empty in both directions. How am I gonna do that? Yeah, maybe we don't want that. Maybe we want it on the rows. Okay, back to where you were. All right. Func test empty table knows its row headers. Already knows its row headers. Okay. And table equals scale degree table. And let's assert equal column headers. I'm sorry. Row headers. Well, it's going to be an array. And with what we have, Hmm. Well, I think we're going to say greater for the first, then 7 plus. I don't know. This is the potential headers. Going down the page, right? And then 7, 6, 5, 4. So I don't know. The 3, 2, 1, like that doesn't seem like enough. But what do I know? Okay, we don't need this. Well, I guess I don't need to line them up either. Okay, that's the normal ones. And then this row. Oh, no, I do want to make them line up. I don't know why they aren't. Okay, but so I'm suggesting there's going to be a header position that says they're bigger than we thought, and then the upper octave, and then the middle, and then the lower octave, and lower than that. Okay, but we don't have this. Row headers. And I guess this is public. Well, this is one of those can't go wrong things, but we'll do it slow. Now I wonder if we should be data driven on this. I just don't know. So in other words, if it used 5 plus and then 4 and then 6 minus, I would have the range between 5 plus and 6 minus and not have any others. I don't know. I guess let's get a report written and then we can critique it. All right. So we're not doing any special stuff here. Okay. All right. So what else can we get from an empty table? Rows or scale degrees, increment, fetch. Well, I guess it would be fair to ask the number of columns and the number of rows. Has no columns or headers. So this is assert equal table dot column count should be 0. Actually, let's Okay, yeah. Column count. I'm leaving that like this because it's kind of public information. We'll need it to draw things, so I guess I want to know it. All right, and then, I mean, clearly it's a fail for now. And for now it's 0. That should pass. And similarly here, table.row count should be table.row headers.count. Okay. That should fail. Doesn't build. Row count doesn't exist. There we go. Maybe this is this lazy thing. I know there is a lazy initializer. Can he rely on things? Not calculated to the first time he's called. Right, so we're saying don't recalculate it, just calculate it once. Okay. Right, okay, well, we're not using it that way. Lazy var row count is row headers dot count. And the reason I'm doing it this way, we can't you give it a you're giving it a closure and you're saying run that when you access it. Lazy var, okay. Row count and equals, and then we're going to calculate row headers dot count when it's called, and it's not called until it's accessed. Okay. Right, and this should pass. Okay. Now, again, let's go to this. Column numbers are measure numbers and note numbers. We sort of know that. Fetch run column headers. That's done. I guess I should pull this over into our to-do. I don't know what his thinking is there. Is that weird or what? Okay. I don't even know what to say. Okay. Scale degree counter table. All right, so we've created the table. columns, rows, or scale degrees, fetch row and column headers, fetch cell. And those are more that's kind of information about it more than something we're doing. Okay, so now we want to increment a cell. We sort of started this. Well, let's split it. Fetch row headers. That's kind of ongoing. Column header, no. That's done. Column headers is the ongoing one. So row headers doesn't change, at least the way we're doing it now. Okay, increment a cell, fetch the cell. Let's look at that. Count totals by scale degree, measure, and note number. Okay. Show counts in table. Yeah, that's a visual thing. Okay. Increment a cell. Okay, so let's go back to our test. Increment a cell. How about implement non-existent cell, creates it with count of 1. True enough. Okay, so we create a table, and let's do table.increment. And then what we're going to do is some scale degree at note and measure. A scale degree 3 octave 0. Okay, and then the measure is, let's say, 1, and the note is 2. Okay, so we're creating a new cell to put it in, and then we increment it, and then that should all be there. And if you did let value equal, let result equal table dot at scale degree 3 measure 1 note 2. Okay, we should be able to say result should be 1. And, well, I don't know if I want to say and just yet, but these two things should change. We'll put dummy assertions in for now. They're not going to change just yet. All right, we don't have an at, we don't have an increment. Okay. Increment, and we want a scale degree. and a measure and a note. Did I say note number? I think that'd be better. Note number and we'll do nothing. And then we need a fetch. Can I do this? I wonder if I should do subscripts for this. I think I can do 2D ones. Yeah, I can. The first is degree. The second is measure. The third is note number. And it returns a count. Okay. Let's see if I can do it this way. I wonder if I can do that. Why don't you have scale, degree, and scope? He's in the top half. Scale, degree. I think we'll just force a build. Or clean. Scale degree is public. Well, it says build succeeded, but still complains. Well, let's see if this test runs. This test should fail because, well, let's make sure scale degree is in the right project, I guess. Scale degree. TuneSim, yeah. How about this thing? Uh-huh. Okay. Run those tests again. Okay. I don't know. Does this seem odd without the names on there? Extraneous subscript labels. So maybe I'm not allowed to do those. Subscript, nothing, measure, note. Okay. Build again. Why it wasn't extraneous a moment ago? I don't know. Okay, -1. Good. All right. I want to be realistic. Okay, so I guess we have to do the work, and maybe this is the moment. Okay, so what's happened is we come in here, and the degree table right now, well, we have no underlying table for one thing. Okay, so we need one, and it's, well, if it were a table of counts, but it's really scaled to, I think it's 3 levels deep. Okay, like that, and it equals nothing to start with. So the first subscript is scale degree, the second one's measure number, and the third one is note number. So I think even this, what I'd like to do is say every row exists, but it's not. Oh, I can't do that either. Oh, yeah. I don't want to redo a bunch of stuff, but I really want 1 row per header. Okay, so okay, let's pull that out. Static let row header names equal this stuff. Okay, now this table, well, what does that change? Column, row header, row count is now, we don't need lazy anymore. We can just be, well, actually, that's probably okay. Row header names. Can we use an instance? Oh, sure. Row headers. Can I just initialize it this way? Scale degree table dot row header names. Will that work? Okay. Okay. So now I have the row headers. Okay. So what I want to say is array repeating empty array, meaning no measures, and the count is scale degree table dot names dot count. So I'm creating 1 empty row for each one to start with. Okay, I mean, we could do it differently, but that's what I'm doing. All right, so 1 empty row for each one. All right, so the array, if you take the measure number, you get the first bracket, the middle bracket. You take the note number, you get the third bracket, and then you get to the count. Okay, so now what happens is well, to put something in, we're going to have to make sure it's it's measure number is there. Okay, so I think what we can do, right, nature, I don't know if I want to build that in. In general, it's increasing and never decreasing, I guess. That's what I want to get at. So whatever it is, if it's not big enough for the one I want to put in, then I should just grow it until it is. Okay. And so if the scale degree exists, okay, so we can say, let's see, I think we want to do this. We want to say while or maybe it's just, maybe we can just compute it. Okay, so if we take table sub degree dot degree, is that right? No. Oh, so deep. Let's say there's some degree to index of degree. Okay, so that's the one we need. Well, yeah, that's that. Table sub degree of index dot count. Okay, let's do this. Let current, let degree entry, I don't know, maybe I should take a smaller bite. Let's do that. Let's simplify our test. We'll put scale degree doesn't matter. Measure 0, note 0. Okay, I think that'll make it a little easier. Okay. So the degree entry, well, right now we know that this is 0. So whatever degree we got, that's the index, and we want to append an empty array of measures. Okay, and then this little function, oh my goodness. We'll make him private func degree to index of degree of scale degree, returns an int so we can access the table. All right, and let's just return 0 for now. I know this is not correct, but we're going to do the same thing on the subscript side. We're taking shortcuts here. Okay. We know the table at that position is empty because we know his count is 0. Let's say that. If table sub degree to index of degree, his count is 0, then we're going to append something. Now he's got one measure. Okay, let's pull this out. Well, is extract variable going to work for me today? Yes. Okay, so this is the degree index. Okay, is that. So degree index. Okay. All right. If the measure number is not there, okay, then we're going to increase it. We're asking for measure 0, so we know we need to increase it. This is hard coded. Okay. Now we need to worry about is the note entry there. Okay. So if table sub degree index his count is 0, that means the measure doesn't exist. Degree index of note number. Well, I guess if the degree index doesn't exist, measure.append is the note array. So we're going to append that. Okay. Something's wrong, right? Degree index of measure dot count is 0. And now finally, degree index measure note number. I don't know why he's forgetting the names in here. If his count is 0, we haven't created. Okay, things are looking a little rough here, aren't they? Somewhere I need to set the count of this thing. Yes, I did. Thank you. Okay. So, why is that one okay and that one is not? His type is array of int. Okay. So why can't we append to him? Oh, he is array of int. Do I have too few brackets? Okay, if I access the scale degree, I get the double array. If I access the measure, I get the single array of notes, int counts. And if I access note number, I get count. Okay. Table sub degree. No. index is an array of ints. Okay. If table degree index is, that's an array of ints. Should be indexed by measure number and then note number. Okay. That seems okay to me. Am I jumping ahead here? Yes, I am. No, I'm not. Take degreeindex.count, degreeindex.measure.count. Empty note counts of type array of int equals nothing. I'm hoping it's a type. No exact calls. Degreeindex to measure should be an array of ints, yeah? Okay, an empty one is this. And then I want to append whatever it contains. It should be an empty array of ints. Append new element of type int. And what's this one doing? Dot append new element of array events. I think I'm losing a level here. Sorry, gosh, it's been a while since I even did multi-dimensional arrays for stuff. Actually, I don't know if I've ever done it in Swift like this, 3 or 4 levels deep. Okay, so the array events is an array of counts, and the index is note number. This array, the index is measure number. This array, it's scale degree. Maybe I'm missing a... Okay. Table of degree index should be... new element of type array event. Okay. And then, if we don't have enough for that, let's append 0. I guess I just have to believe it because it's telling me the right thing. Okay, so we append the array of ints. When we try and index it, I guess we're okay here. Get the actual increment. Okay. Oh boy. No exact matches in calls to subscript. Oh. Oh, I'm doing this wrong, aren't I? I know I'm not. No exact matches. No exact matches in call to subscript. His type is array of array event. Okay. Of measure should be one array. Sub note number should be a digit. Oh. Okay. So that should build. And I think it should pass. Oh, we haven't dealt with the reader yet. Okay. Ugh. That one's easier. Okay, so the write should be okay, but the read's going to fail. Where are you? Okay. Result of 1, it always returns -1. So there you go. Okay. Well, it's going to be this, more or less. Degree index is our degree index. Okay. And what's weird, well, is that happy from a build stage? If this thing doesn't exist, we've got a problem. Run. Now I hope it passes. Yay. Okay. Handle simple case of adding and fetching and fetch a cell. Woof. Okay. So we took the trouble up here to add the measure and indexes and all that we needed. Okay. I think I'm going to just let's do I want to deal with this? I think I want to keep these off the table for now. I don't want to forget to do them. Okay. Scale degree 3, but we only handle the first measure with the first note in any given row. That's not what we want. Let's take the case of measures. So if I do measure 2 and that, we'd like that to pass, but I'm pretty sure it's going to crash because we only add one cell. Yeah, boom. Okay. All right. So the problem is we only handle adding one cell. We only worry about the count 0. But if it's 1, we haven't we don't add enough cells for it, enough rows. Okay, so let's stop that. All right, and so the problem is it's the table degree index dot count is 0. We want it to be 1 because our scale degree index thing. Well, it only returns 0. Okay, let's get that working. Okay, so this, okay. I think we got, oh, how do I want to do this? Well, row 0 is always the case where your octave is too big, okay? I don't know if we can justify this, though. So what's happening is I'm being pulled to make this public, which maybe that means there's a missing object, or, you know, this column header, row header names, and count and all that. Maybe that's its own thing. All right, but so if I had a scale degree rows, I could ask it, well, what row, what index should I use? Not bad. It would own the row header names. This would reference them. Let's do that. I hate to stack up stuff. Okay, I'm gonna put this back to 0. And 0. Okay. And it's working. No, well, we were returning 0 there. Okay. Right, that was more helping us along. Okay, so is there any difference? I don't think it's much. Okay, did code. Okay. Did code and comment out part of test. Okay, and I don't normally leave comments around like this, but so far it only works for degree 0, 0. Okay. All right, so what I want to do, I want to create a scale degree row. Scale degree rows that maybe has information about the row structure and knows how to get from scale degrees to row names and stuff like that. Okay, so it goes in our section here. A new file. Scale degree rows, and well, while I'm here, and then down here in our tests, and I didn't put that in the right place. Oh, I did. Okay. Cool, I guess. Okay. Now, test. I think we can get, well, this is the sort of test we want. Okay. I guess since they're rows, they are headers, row headers. Header names. Okay. I don't think we need that one. Okay. And scale degree rows. Let's get you up there. All right. Scale degree rows tests. Okay. Now rows headers. Where's scale degrees? Let's pull that out of here. Oops. Okay, and we have our test, wherever it went, row headers. Okay, so let's say public lazy var row headers equals row header names. Excuse me. All right, and row headers. Okay. I think you'll find it does. Okay, and now scale degree table doesn't need this. I'm just going to call this headers. I don't know if I'm going to regret this, but okay. Let's make sure his location is good. Okay. So scale degree rows headers.count, and then the row headers. Yeah, it's like we really need to make this. Oh, gosh. So I don't know if I should just give this. Row info.count. Okay. And this is row info.headers. And this is row info.count. And the reason I distinguish these is the row count here. We could change our mind and have other rows that had nothing to do with this scale degree stuff. And then we would have to take those into account. But okay, I think that's all right. Once we get access to this. Oh, this was wrong. That's not tests at all. I don't know why it's guessing completely wrong. Okay, anyway. All right, so we're providing these things. Scale degree rows. Cannot find scale degree rows. Okay. Let's scale degree rows. Scale degree rows is in TUNE-22 macOS for sure. Okay, now where's the failing thing? He is in TUNE-22 macOS, so he should be good. And he can't find it. Cannot find scale degree rows. Wait, TUNE-22 iOS. Scale degree table. Scale degree table is in TUNE-22 iOS, TUNE-22 Mac. Okay. Scale degree. That's the same thing. Scale degree rows is in TUNE-22 iOS, TUNE-22 Mac. Both of them can't find it. Okay, I'm going to restart this thing. I'll tell you what. Let's take a 3-minute break while we're at this pause here. And I'll see you in a few minutes then. All right, welcome back. Looks like the reboot cleaned the whatever it was confused about. This last version has seemed more buggy to me than previously. All right, but we are ready to run tests anyway. Okay, so we have some scale degree row tests. And that should pass. Oh no, still can't find it. Oh, you got to spell it right. Why didn't it catch it? Okay, another complaint. Static member iOS row info. Oh, I think I have to just say scale degree table dot, right? Yep. Same thing here, right, guys? Okay, try again. Value of type scale degrees rows has no member. Oh, we need headers. Let's get the count in here too. What? When have I ever asked for not equal? Okay. Rows dot count. And it should be 1 plus 3 times 7 plus 1. Okay. That's 3 different type of rows. Okay. Should pass. Good. All right. And then let's move scale degrees over. Scale to index. Sorry, this function. Degree to index. Okay. Scale degree rows. Putting it over here. And then scale degree row test we want. Do we have a test in here? Not directly for the index. Okay, so now we're in a position to test those. All right. And I think what I want to do is, let's see. Well, it returns 0 for now. Yeah, let's deal with the test. Okay, so degree to index. Okay, so I have to create a degree. Scale degree. Degree. Let's start with let's start with degree 1, octave 3. Okay. Now we're only going to handle octaves 0 plus or minus 1. Okay. And we want this to return index 0, for that's the greater because it's too big. Okay. So assert equal. Degree, row rows dot degree to index, which is currently private, of degree should be index 0. Okay, and so this should be public. Whoops. Okay, this should pass because it's the only one that will pass. Okay, and then I'm really should do some sort of table. Let's say check degree octave 1. The base is 1. Okay, so I'm trying to get these. They're in octave 1, and the first one should be at 1. Okay, so let's define check degree. Octave is an int, base is an int, and we want to say let degree 7 equals scale degree of 7 octave. Okay, so we're trying to get that 7 plus. All right, and we want to assert that degree 7, rows dot degree to index of degree 7 should be base. Okay, so if we come in, ask for the degree of 7 octave 1, it should be 1. Okay, and if we let degree 1 is scale degree 1 in this octave we're given. So I'm going to test the ends, XCT AEQ. Rows dot degree to index of degree 1 should be, well, if 7 is 1, 6 is 2, so it should add up. So it should be 7. 7. Okay. Now, okay, so I'm checking those 3, and then octave 0 should be the base of it. Since the last one was 7, this should be 8, and then this should be 15. Okay. And finally, let's make this degree low, high. And let's make one that's similar, that's degree low. -2. And the index of this should be, well, it should be rows dot count -1. Okay, so the count is the number of headers. The last one is going to be should be the last one in the list. Okay, so I think I've expressed all these, and now I'm going to take them a little slowly. Well, no, I think these all come for free. This one's a little trickier. Free being relative. Okay. It is a little mind-bending, I guess. We're kind of mapping things funny. Okay. This test should fail. that should be okay, but the check degrees should be all crazy. Okay. We expected 0, we got 1. We expected 15, we got 0. We expected 8, we got 0. Guess we expected 1, got 0. Everything's 0 the way this thing works. It's always 0. Okay. Well, we know if degree.octave is greater than 1, then it is 0. Okay, so that's true. Otherwise, we want +1 to map next. Okay. Well, I think it'd be easier if we flip the sign. Okay, so if we take the negative, let's see, we're taking the negative of the octave. Okay, so now that's negated. Well, it should be base plus some octave size times this plus some offset. Yeah, with an offset. Okay. Well, the offset is 1 because the new base should be 1 with zeros coming in. So if we take the octave and flip it, we get -1 plus 1. Okay. So let octave position is minus degree.octave that plus 1 minus times, well, it's 7. We'll get that magic number out of there in a minute. Okay. But if I take that 7 times that, so the +1 octave is -1 plus 8. I'm trying to get this thing moved up to our base. Okay. All right. So if we take 7 plus, the octave is 1. Negate it, it's -1 times 7 is -7 plus 8 is 1 is our base. Okay. So that gives us the base of 1 for the positives. If we take octave 0, then the base is 0 times 7 plus 8. Okay, so it's 8. Good. And then if we take -1, we flip it, it's +1 times 7 is 7 plus 8 is 15, and we got the start of the -1s. Okay. We'll get, okay, that gives us a start. Okay, now let degree offset, maybe I'll make this base. Base and offset have a nice long history. Okay, so if I have my, the problem is I want them backwards, right? Because I want 7 first. Okay, so if I take 8 minus it, I'm going to get 1. 8 minus 7 is 1. I guess I'll take 7 minus it. 7 minus that is 0, puts us at 1. 7 minus 6 is 1, puts us at the next one. Okay, so let's take minus degree dot degree. And we want 7 minus that, right? Is that what I said? Degree is 7. We'll take 7 minus 7 is 0. 7 minus 6 is 1, and so on. Okay. And then we're going to return octave base plus degree offset. All right, run that test. The low one should fail. Oh, we commented that out. Ugh. 2 failures. That's weird. Okay. 1 is not equal to 15. 14 is not equal to 7. I guess I want to say run that again. Can I find degree in scope? Okay, degree 7 is that. We want it to be degree and octave. I'm not sure that's going to improve my messages any. I don't know. Degree 7 plus octave 1. Seven. Wait. Where's base? Should be. What? Okay. Sorry. This should be base plus 7 is what I want there. Or plus 6? Yeah, plus 6. Of course, it's still going to fail, so we're just getting a message. I hope it's a little better. Okay. So, degree to index. Degree 7 plus. We want 1. But we got 15. What's this octave stuff? Yeah. That should be minus 1. Okay, because we want 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 15. Should be the base for that. Okay, let's try this one more time. Hopefully I can get the test straight. Okay, yeah, it's a test problem. Cool, I guess. I mean, the code's a little trickier than I like. Let's get... Tell you what, let's make this last test pass. This one. And I believe that's going to fail right now. that can't be right. Rows.count minus 1. How are you? Oh, yeah. Okay. Let's make it 6. Seven naturally calculates out to that position. Okay, 6 does not because it's out of range. Okay, so let's go back here. Degree to octave. Octave is less than minus 1. Return rows dot count. Well, I guess it's just count. Count minus 1 will be the index. Okay. Okay. Let's work on these constants. Okay. I make this the other way around. Excuse me. Is that right? All right, so I think this might be better like that because that 8 is coming from the fact that, well, we have to allow an extra offset for this thing, and the rest of it all 7s because there's 7 notes in the scale. Okay, so okay, I don't know. We can, maybe it's note names in scale. Now that does seem funny, doesn't it? This minus x times that is really like x plus 1 times that. Okay. Let's factor that out. It's no names in scale times 1 minus degree. I don't know. Doesn't seem better. Make sure that's all still legal. Okay. And now the tests, are they looking okay? I think that's okay. All right. Make scale to degree, work for all values. Okay. You can see we're pushing towards our real program. It's this little chain of stuff. So we had to be willing to defer. Let's this is really let's just take rows. Degree to index. We don't have rows, do we? Well, we can do it here. Okay. So we delegate. All right, let's push. Okay. Now, I think we've improved things. Okay, column count. That's a good question. It's not that. Neither is that. Okay, let's get our calculations right first. Okay, so the scale degree test only works for 0, 0. So let's do one that puts it in measure 2 and looks it up in measure 2. Okay, and what do we got going on here? Increment cell for measure. Well, this is scale degree cross measure cross note number. Which I think is redundant to this. Okay. I think that is what we are in fact trying to do. Okay. This should fail. Our scale index is right, but it's going to crash when it grabs the wrong place. Okay. Because there's nothing in there. All right. So I think the problem is we only allow for measure 0. We just created this one append, but we wanted to put it in measure 2. Okay. So what I propose to do then, if it started out with a count of 0 and we wanted to put 0 in, we'd have to append once. So I think what I can do is make this a less than or equal. Okay, so while the count is less than or equal to the measure number, we don't have a slot for measure whatever. So we want slot 2, we have to make sure the count is 3. Okay, so while the count is, when it gets up to 2, we're going to put one more in. That's the one for 3. All right, I think that will help. All right, now we have the same problem in the note numbers. Okay, so if we make note number 1, and we access it, it should be 1. Well, let's put 2 increments in. Yeah. Okay, so it should be 2. And this will fail for the similar reason. Okay, out of range. And that's because this one only appends notes in if it knows they're there. And we're going to use the same logic. While the table degree measure.count is less than or equal to the note number, we're going to add zeros in. So anybody we didn't get anything for, if we're trying to put in slot 2, we didn't fill in slot 0 or 1, we still have to fill in those zeros. Okay. Right. And I expect this to work now. The first one was definitely the expensive one, wasn't it? Okay. Now this, I don't think we have to do this anywhere else. So I'm tempted to leave it here. They are different. Okay. Let's push this. All right. So make table allocate cells for any address in use. Okay. Now, I guess one little interesting twist in here, this second one doesn't do any creating. It just does the incrementing. So that's cool. It didn't go off into some weird place. Okay. Now column headers. Oh my gosh. Column count is probably easier. Well, no, you can't count columns until you can count headers. Because we want the overall count of the measures. I don't know. I don't know where to count these. So we have a choice. We could keep track of it as we go, or we could allocate it as we need to. Okay. So the other thing I want to do, maybe before we do that, let's test fetch 0 for non-existent cells. How do we want to make that work? Okay, I think we can. Let's see. So we'll need a table. Okay, and a degree. I think note 7 and octave 1. Okay. So what I want to say is if I get result equals table degree 32, somewhere we've never mentioned, this result should be 0. Okay. As opposed to blowing up. Good. Good that it's the expected failure. Okay, so the problem is by the time we get down here, we're hitting indexes that don't exist. Okay. And I think we'll do a similar test. Let's do a couple. Yeah, we'll do this one first. Okay. So the problem is degree, we put all the ones in, we have a row for each degree already, but we don't have a column for it or a measure for it. Okay. So we don't expect this to ever fail, this part to ever fail. So let's build the pieces. Okay. Let measures equal this. Table degree index dot that. Okay. Now, if measures dot count is 0, is less than measure, return 0. Okay. Okay, so if we have measures 0, 1, 2 in the table and we ask for 3, measures count, I guess measures count, if it's equal to measure, that's still a problem. Okay, so there's 0, 1, 2, we ask for 3, count is 3, measure is 3, should return 0. Okay, and then at the end we're going to return this. Now that's still going to blow up. Okay. because we had a note number that was also out of range. Oh no, it passes because this one kicks out before we get to the note number, but we're missing code here, so we need a new test. That's what I'm trying to say. Okay, so let's say non-existent measure, and this is non-existent note number. Here it doesn't matter that it's non-existent because it never gets that far. Okay, now if we ask for, well, let's say we put something in table.increment degree measure 3 note 1. Okay, so the note before, and then we ask for number 2. Okay, that's all still set up, arrange. Okay, so we create a table, create this, insert a node in the right measure, but not far enough along to let us access this. We still want to get a 0 back, and I think we're going to get a blow up. Okay, good. And scale degree. Okay, so measures.count. Now we know it's, we know the measure number is less than the count at this point. All right, but if measures submeasure dot count is less than or equal to note number, then again we failed. Okay, otherwise, whoops. Otherwise we're going to return that 0. So we're in measure, well, let's say it's measure 2, looking for note number 3, and we've already got 0, 1, 2 in there. 3 is less than or equal to 3. Yes, return 0. Okay. All right. Oh. We're getting there, but it's painful. Okay, let's see what we got. Increment cell for each number that we've done. Well, we've also done fetch the cell. Okay. Now we want to fetch column headers. What were the two things? Column count. Well, maybe I don't care about column count. Let's see who uses that. Because they could always ask the headers. I think if that's what they want. Well, we know it's only tests so far. Okay. That, let's take that out. I tentatively think it's waste. Because if you know the headers, you can count them and that's fine. You're going to put them, the reason you're going to count them is because you're just about to use them. Okay, so let's go back to the test. So that goes away. Okay. Now, all right, so I think here what we've implied, let's format this a little. Okay, what's going to be in that table? Well, we say there's a number measure 2 and a note 1. So we go back into the domain of what we want to see. It's going to be 3 measures and 2 nodes. So measure 1.1, 1.2, 2.1, 2.2, 3.1, and 3.2. Okay. Now, I don't know. Is that going to make it clear? This is really 0, 1, 2, and then within there's 2 numbers. So we're going back out to the countable number domain from the 0-based index domain. Okay. I'm going to add one more in. I just want to make sure our counters and increments and all that are the right ones. Okay. This should pass up till line 33 and then fail on 34, since we always return empty. Okay. Yeah. Failed empty is not equal to that. Okay. All right. So what I think we want to do is capture the maximum. This may be overkill, but normally you're going to quantize your music coming in so that you only look at quarter notes, and every measure is going to have 4 quarter notes, and that's going to be fine. If we do that, then the measure number, if we capture the maximum measure number used anywhere and the maximum note number, then we multiply them, or add 1 and multiply kind of thing. That gives us the number of notes and stuff we need. Okay. So I think that's doable in there. Okay. So the degree table. So I'm saying we need to keep track of, we don't need scale degree because that's a fixed range. The maximum measure and the maximum note number. Okay. So let's keep track of them. Highest note number, and highest measure. Let's start with 0. I don't think I want to use -1s because 0 at least is valid. We could show report with 0 and then it would be fine. Okay. Of course, if we have none, maybe that's, let's start low. The first time we do anything, it's going to become set, so it's not a super big concern. All right. But when we do an increment, not the other. Okay, if we actually increment, well, this doesn't matter. We can keep track of it here. Okay. So highest measure equals, is it int.max of highest measure and measure number. Similarly, highest note number is maximum of highest note number and note number. Okay. Cannot call value of non-function type int. This is a readout max, yes. Set max. Does int not? It suggested max, so I'm kind of believing it. Int.max. Or is that the number, the maximum number? Really? There's no... So standard library, well, there's int. I guess let's go in there. That's not a lot of maxes. Okay, we'll define our own. Okay, I don't feel bad about that one. All right, now, well, if the highest measure is less than 0 or the highest note number is less than 0, I would say this is more of a guard clause. Highest measure greater than or equal to 0. And highest note number is greater than or equal to 0. Else return brackets. Okay. Let's try that. Okay. So we expect, let's just, what? Okay, yeah, we certainly expected some of our tests to fail. Scale degree tests. All right, this gets the wrong columns again. Okay, notice this one passed because those things did start negative. Okay, so now we got to do the work. All right, so we want to do, basically we want to do a nested loop, I guess. For the measure in 0 dot dot less than highest measure, I guess dot dot dot, that was the highest measure we saw. And then for note number in 0 dot 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 highest note number, Okay. And then var result of string equals nothing. And then down here we'll return result. Okay. We want to append well, we would like measure plus 1 dot note number plus 1. Okay. All right. I think that should pass. All right. Compute row, nope, column headers. All right, now where are we? Fetch column headers. All right. I'm not going to put the mode stuff is going to wait. All right. We can do it, but it's not the most important problem at this point. I think we've done what we need to for the table. Show counts in table. I think that's the headers we just did. Compute the scale degree for each node of the measure. Okay, we haven't done that. Okay. Compute the scale degree for each node in each measure. Okay. For each position and measure, count the number of nodes of a given scale degree. I think that's the same. The mode we're going to make extra. Okay, compute the mode, compute the scale degree for each one, and then we need to write the text report. And then down here, we're going to write a graphical report. We don't have that yet. That was our failed spike. Okay, I think we can probably do a lazy V grid, which is the vertical grid. I don't even know if it has to be lazy, but we can do them in blocks and get more than 10 things in there that way. Okay. And the columns, I think that's just going to be a horizontal stack. There's nothing special about it. We'll probably draw more than you would have to for the laziness, but that's okay. Okay, compute the scale degree for each note and write the text report. Well, this is really the computation involved in the text report, I think. Somebody's got to go through and write stuff to this table we've painfully constructed here today. Okay, let's see. So let's go down to the report. The stage. Okay. Consume is doing the work. All right, so that's the thing that needs to do it. All right, so let's say fill in the table. Let's let the table equals a scale degree table. And then we're going to say populate table. And then we're going to say output equals generate report of from table. Okay. Actually, and the input.metadata. Go look at that packet again. It's got the tunes and it's got the metadata. Okay, so I guess the, oops. the table is going to need the tunes. Input.tunes. And let's just put them in the same order just to be a little consistent. All right, and then if this gets too big, we'll deal with it. All right, so private func populate table of scale degree table and tunes of tunes. Wait a minute. Underscore tunes of capital tunes. It's just changing the table so it doesn't have to do anything. And then generate report. Another private function, generate report. Takes the table. And the metadata. Just still a string. Okay. And we'll make that return a string, which is currently TBD. All right. Oops. Input.metadata. Okay, so I'm just kind of where I was. I guess if we'll run it just because we don't have tests on these graphical things. Okay, so melody average. Let's take this. It doesn't matter what we open. We run it and we get the TBD we always got. Okay. I know, a little weird. Good though. It's a step. Let's extract a report. Yeah, let's create a class. This is the average tune report in those two, yes. Okay. And we're going to extract stuff from this thing. So really we want these two plus a little. Oh, you went away on me. Okay, let's call it generate. Public function generate. You're going to give me a packet, I think, and I'm going to give you back the string. Okay, and we want this. Well, let's let report equal average tune report dot generate for input. Okay. And then over here, that is this. These go away. And this is report.generate of input. Let's try it like that. We're going to get that same empty thing if all goes well. Right, that's what we've done so far. Okay. Now, these functions come out of here because they're not being used. And this is not, in fact, iOS specific. Anything wrong here? No. I'll trust myself in those two spaces. Okay, separate rate average tune report from average tune stage. Okay. And I'm separating it because I think it's complicated enough on its own and we can test it separately. All right. So we need a test. So it's here tests. Okay. Well, what's our test? So we've got a scale degree table. We're going to populate it based on the list of tunes. So we're going to have to be doing some walking through the list of tunes, and each tune we're going to have to walk through its measures. Walk through its measures, and for each measure it's got a series of notes, and we're going to tell the table put the note in. Now if it had a rest there, I'm not quite sure. I guess we should just, we don't have a scale degree to put in, so I guess we'll just do nothing there. Let's go look at our original. I didn't notice a rest. Oh, that's the 0 probably. Well, I don't know. Was 16? Maybe all these 16 had it. Again, I don't know. Okay. Let's add that to our to-do. It's not something to solve in 7 minutes. After we do the report, we're going to say handle rests, new row, which I think is how we want to do it. Okay, so we're only going to include notes in, and that's easy enough. Okay. Well, it'll be a little challenging, but okay. Scale degree, we don't need this. Tune stage, probably not. Report, yes. Report tests, yes. I think we'll take these out for now. Okay. Well, the easiest way to start is a tune with no notes. Tune with no notes has no columns. Let's check that, I guess. All right, so we need a report. Create the average tune report. Report.generate. Well, this is a packet with tunes of nothing. How about reports metadata but has no columns? And the metadata can be meta 1, meta 2. Oh, I think it's just a plain string, isn't it? Packet. Yes. Packet. Yeah, it's string and you always append it. Okay. Okay, so packet of tunes and metadata. All right. The output should be, well, I think it should be metadata, new line, 2 new lines, and nothing. Okay. No headers, no columns. Do we draw them? I would say no. I think we'll draw any row for which its contents are non-zero. All right. But let's see. This is tunes of nothing. Oh, come on. Okay. Test should fail. One failure, good. Okay, we got TBD instead of metadata. All right. Report. So it should write, well, it always writes metadata. Metadata followed by a new line. And then metadata contains its own new lines. And a string. Well, let's compute the output. Generate report from a table. So let's give it a table. Empty table. Okay, so well, let table contents equal nothing. I don't know, I'm putting a little dummy stuff in. Okay. Oops. Oh. Oh, I didn't put my new line in my test, did I? I suspect that's the problem. Yeah. All right, there's our start for the next session then. So we'll meet tomorrow and focus on the report. It's going to be 1 to 3:30 p.m. Eastern Time or 6 to 8:30 p.m. UTC. I think we made good progress today. We got that big table thing done to some level, and I think we can go from there pretty happily. All right. See you tomorrow or next time or sometime in the future, I hope. Take care. Bye-bye.